Imagine a world where everyone uses AI every single day, for work, play, and life. It feels like pure magic, instant answers, endless creativity, but that magic has a hidden cost. Every AI response takes massive amounts of energy hidden deep inside vast data centers. These machines never sleep, burning electricity around the clock to power intelligence. The more people use AI, the more energy the world needs to keep it alive. It's easy to forget this when you're just typing a message on your phone. But behind every word you see, machines are running non-stop, consuming power. This hidden demand is quietly reshaping how the world produces and uses energy. Soon, energy, not innovation, will be the biggest limit to artificial intelligence. Experts now warn that AI could soon consume as much power as entire countries. To keep up with demand, the world is building new data centers every single week. But energy doesn't appear from nowhere, every watt must be generated somewhere. What began as a software revolution is quickly turning into an energy crisis. Each new AI model adds pressure to the already stretched global power grid. The miracle of intelligence now comes with a physical price, electricity. The faster our models grow, the more energy they burn to keep learning. If everyone used AI assistants all day, we'd need 20% of the world's power supply. Add video and memory, and that number skyrockets beyond imagination. We would need hundreds of new gigawatt-scale data centers just to keep up. That could cost trillions of dollars and push the planet's limits. Clearly, our old way of building computers cannot scale forever. Somewhere, a few scientists started thinking differently. They founded a small company called Extropic and dared to redesign computing itself. Their goal was not just faster AI, but smarter, more energy-aware intelligence. They asked a bold question: what if computers worked with physics, not against it? Instead of forcing perfect answers, their computers would embrace probability itself. Because the universe itself runs on chance, not certainty. This led to the birth of a new kind of chip, the thermodynamic sampling unit. It doesn't calculate like a GPU, it samples, learning through patterns of noise. Where old computers fight chaos, this one turns chaos into power. Traditional chips follow strict rules, Extropic's chip learns from randomness. Instead of crunching numbers, it samples possibilities. Each chip cell acts like a tiny universe making its own random choices. Together, millions of cells form a living map of probability. To make this work, Extropic had to redesign AI algorithms from scratch. These new algorithms don't just calculate, they simulate nature itself. They call it the thermodynamic sampling unit, or SU. Unlike GPUs that multiply numbers, TSUs generate random samples with purpose. Every cell talks to its neighbors, sharing signals and adapting together. It's a machine that learns by sampling millions of tiny possibilities each second. For the first time, hardware and nature speak the same language, thermodynamics. By harnessing natural noise, the chip turns uncertainty into efficiency. It may look crazy now, but it could solve AI's energy crisis forever. Most people said it was impossible, but the physics said otherwise. Extropic's prototype proved that random noise could compute real results. Early tests showed 10,000-fold energy savings over traditional GPUs. The idea spread quietly through labs and research centers worldwide. Some called it madness, others called it the next revolution in computing. Because if it works, AI could grow without draining the planet. Extropic was no longer just a startup, it became a movement toward sustainable intelligence. Soon the world's brightest engineers wanted to join the mission. They worked across physics, hardware, and machine learning as one team. Step by step, they built the first working probabilistic circuit board. Noise was once a problem, now it became the source of computation. Every transistor became a tiny dice rolling with physics. Low voltage operation turned thermal noise into useful randomness. This was computation inspired by the laws of nature itself. Each experiment brought them closer to a new era of AI hardware. The goal was simple: make AI powerful without power hungry. With SU chips, AI could scale without melting the grid. It was like teaching machines to breathe instead of burn. Early TSUs were small, but their potential was huge. Each prototype proved the math behind the madness. The data proved it. Probability could outperform determinism. For decades, we made computers fight noise. Extropic made them use it. It was the most counterintuitive idea in modern computing. But innovation often looks like madness until it works. The team knew they were onto something that could change everything. Because in every random spark of noise, there was a new way to think. And in that chaos, Extropic found clarity. The SU wasn't just another chip, it was a new philosophy. It turned physics into computation, and heat into information. Suddenly, computation wasn't about brute force anymore. It became about elegance, doing more with less. If successful, it could change the way every AI on Earth is built. GPS ruled the past, but TSUs could define the future. Extropic proved that innovation doesn't always mean adding more, sometimes it means using less. The world's biggest challenge now had a smaller, smarter answer. What began as an experiment turned into a blueprint for sustainable AI. It wasn't science fiction anymore, it was working technology. The results stunned everyone who saw them. Suddenly, energy efficiency was no longer a dream, it was measurable. TSS could one day power AI everywhere, from phones to satellites. Instead of chasing speed, we could now chase balance. For the first time, intelligence could grow without consuming the world. What started in one small lab could reshape global computing forever. The next era of AI won't be built with more power, but with smarter design. It's a vision of intelligence that works in harmony with physics, not against it. A small team dared to question everything, and built the impossible. This is how Extropic is teaching machines to think, the way the universe does.